If I told you that right now, there is an object passing through our solar system that, according to everything we've ever taught in textbooks, should not exist in this way, you'd probably assume it was just another clickbait headline. But here's the unsettling part. The scientific community isn't dismissing it. They're not saying it's aliens. They're not saying it's extraterrestrial technology. They're saying something far more uncomfortable. We're not sure it's a comet. And when something looks like a comet, moves like a comet, but doesn't behave like a comet, the real question is no longer where it came from. It's this: what exactly are we looking at? For months, this object was given a very familiar label: an interstellar comet. An icy visitor ejected from its home star system, wandering through interstellar space for millions of years, before casually drifting through our neighborhood. A neat story. Logical. Easy to accept. Until the data started to refuse to cooperate. When humanity's most powerful telescopes turned toward this object, scientists expected to see something familiar: chaos, randomness, messy, uneven activity. That's what comets do. But what they saw instead was too orderly. The jets weren't scattered. They showed structure, organization, near symmetry. The dust didn't spread the way it should. And strangest of all, some features appeared to be pointing toward the sun. Think about that. It's like standing in the middle of a hurricane and watching the rain fall upward. This isn't just rare, it's wrong according to the rules. At first, the assumption was simple. Maybe it was a viewing angle issue. Maybe timing. Maybe noise in the data. But then the chemical analysis came in, and that's when the story shifted. Instead of water, almost always dominant in comets, this object was releasing large amounts of something else. So much so that long-standing models started to bend under the strain. If chemistry isn't your thing, picture it this way. It's like opening a freezer and discovering there's no ice inside, only something that belongs in a completely different kitchen. The scientific community didn't panic. They're very good at not panicking. They said, maybe it formed in a different environment. Maybe it spent an unusually long time in interstellar space. Maybe cosmic radiation slowly reworked it. All of that is possible. But then a different question began circulating. Not in headlines, not in press conferences, but in private discussions. If every anomaly has its own explanation, when does the number of anomalies become the problem? One strange feature is fine. 2 is interesting. 3, 4, 5 at once? At some point, probability starts to feel uncomfortable. Not because it's impossible, but because it's happening a little too neatly. And this is where science enters territory it rarely likes to talk about. The issue isn't whether nature can create strange things. Nature absolutely can. The real question is this: how many coincidences are no longer coincidences? A symmetric jet could be random. An unusual chemical signature could be an outlier. A strange dust pattern could be perspective. But when all of them appear together, on the same object, at the same time, probability starts to speak. Not loudly, not dramatically, just a quiet, persistent whisper. Too many things refuse to fall into familiar places. In science, this is a dangerous zone, not because it's mysterious, but because it sits between explanations. Each detail can be explained on its own, but the full picture doesn't settle. And when a model needs too many exceptions to survive, science has to ask itself, are we explaining the data or protecting a story we're used to? This leads to the most telling moment of all. Not when bold theories appear, but when some scientists stop talking altogether. No declarations, no dramatic claims, just carefully chosen phrases. Anomalous, not fully consistent with current models. More data required. In scientific language, that's a polite way of saying, we're leaving the safe zone. History has been here before. When planetary orbits didn't line up, when the universe was assumed to be static, when black holes were considered impossible. Not because data was missing, but because existing models felt too familiar to abandon. To be fair, the universe is exceptionally good at producing things that look designed, without any designer at all. Order can emerge from chaos. Geometry can arise from randomness. Nature doesn't need permission to be strange. So yes, this object could still be an extreme but natural outlier. That possibility remains entirely valid. But what makes this story compelling isn't the idea of alien technology or extraterrestrial intelligence. It's the realization that we're defining normal based on an incredibly small sample. Maybe this object is the exception. Or maybe we're just beginning to glimpse how diverse the universe truly is. This object will eventually leave our solar system. It may never give us a clean answer. But it has already given us a far more important question. How many anomalies are too many? And when something refuses to fit our existing models, do we adjust the object or the way we see it? If, in the future, we detect more objects like this, then we'll be forced to ask, what do we call them then? If this story feels unfinished to you, if you sense that there are still secrets quietly passing through the darkness, waiting to be understood, follow Ultimate Space Secrets. Because this isn't an answer. It's only the first signal.